Many people have a mobile phone. You probably also refer to it as your cell phone. That term cell comes from the cellular networks that we use to be able to communicate using these phones. These operate by having antennas that separate areas of the land into what we're calling cells. They're antennas that allow us coverage inside of those cells using a number of different frequencies, and all of that together makes up our cellular networks. These cellular networks provide both voice and data communication, and you get to decide how that information is used by your mobile device. For example, you can turn on and off the cellular data functionality and perhaps only use this as voice communication. Or you may be familiar with airplane mode that disables all of the communication on this device, and then you can pick and choose which ones you'd like to turn on. Cellular technology really started taking off with 3G technology in 1998. 3G allowed us to send and receive larger amounts of data over these networks, which means that we were able to increase the capabilities of our mobile devices. This allowed us to have GPS functionality, which we'll talk more about in a moment. We have mobile television, video on demand, video conferencing, and other data-related services all enabled thanks to 3G. We then upgraded from 3G into the 4G technologies. Sometimes we refer to these as long-term evolution, or LTE. 4G is based on a technology called GSM, which is the global system for mobile communications. Sometimes you may hear this referred to as EDGE, or the enhanced data rates for GSM evolution. This allowed us to have bandwidths up to 150 megabits per second, so we were able to take those data capabilities in 3G and expand on them with 4G. We were then able to upgrade LTE to LTE Advanced, or LTE A. That standard allowed throughputs of up to 300 megabits per second, greatly increasing the amount of data we could send over these networks. And our modern mobile networks use our 5th generation of networking, or 5G. 5G was introduced in 2020, and it greatly improved the bandwidth that we were able to push over these networks. This 5G technology over higher frequencies is designed to support up to 10 gigabits per second. And if you're running over other frequencies with 5G, you could have 100 to 900 megabits per second of total throughput. Having that much bandwidth available for a single device changes how we're able to use these devices. For example, Internet of Things, or IoT, now allows much more functionality because we're not constrained by the amount of bandwidth that we could send. So we're able to take these Internet of Things devices over these 5G networks and instantly send large amounts of data over these wireless networks. This allows us to get notifications faster. We can transmit and receive much more data, which allows us to send a lot more into the cloud for processing. Just as our cellular technologies have increased in speed and function, we have also had similar increases with 802.11 wireless. These are high-speed 802.11 wireless networks that we commonly use at home and in our offices. This allows us to have very high-speed throughput without any type of wired connection. These do have limited range, however, and we have a local access point that everyone connects to be able to gain access to the 802.11 network. This Wi-Fi functionality enables voice, video, data, and almost any other type of data transfer. This 802.11 network provides functionality for many different types of applications, and many mobile phones allow you to communicate voice communication over the 802.11 network. So if you're in an area where your 4G or 5G network doesn't have very good signal, you could use that phone over your Wi-Fi network. This allows you to receive and send calls just as if you were connected to a 4G or 5G network. We can also turn our mobile phones into an internet router and have multiple devices use our phone for internet access. We refer to this as hotspot functionality. Our phone is connecting to the cellular network using 5G, and then other devices are connecting to our phone over 802.11. This means that you can take your phone anywhere and have everyone use your phone for internet access. This is something that is commonly built into the operating systems and functionality of our existing mobile devices, but it does require that your carrier enable or allow that functionality. Not all carriers do, and sometimes there's an extra charge, so make sure you check with your mobile carrier to see what options might be available for you. One way that your mobile carrier is able to recognize your mobile device is through the use of a subscriber identity module, or a SIM. This is sometimes a physical card that's inside of your mobile phone, and it contains all of the information that identifies what your phone is on that mobile network. This means that you could potentially take that SIM out of your phone, put it in a different phone, and now you've moved your number to a different physical device. That SIM contains information about the carrier that you're using and the subscriber, which is you, the user of the phone. It has a SIM ID and a phone number associated with it. It contains the information about that cellular network that you're connected to, and there's storage space on the SIM itself that allows you to store contacts and messages on the SIM. So when you move the SIM from one phone to another, you can also move those contacts and messages. Newer phones no longer use a physical SIM card, but instead use an electronic version or embedded SIM. Sometimes you'll see this as an eSIM. That eSIM is a physical part of that phone and can't be physically unplugged and plugged into a new phone, but you can move that SIM inside of that device using the software on the phone. So if you'd like to add or move an eSIM into the phone that you're using, you can choose the option to add an eSIM, and it gives you then options on how you might want to transfer that from an existing phone or to use a QR code for the transfer. Having that eSIM makes it so much easier to manage that transfer between devices. If you've ever dealt with the SIM, which is the physical card, you can see that they're very small. You often need a special tool to be able to unplug or disconnect those, and you can see that this phone supports multiple SIMs simultaneously so that you could have multiple phone numbers or profiles on the same mobile phone device. If you've ever had to connect a Bluetooth device, such as a headset or an external speaker, then there is a process you have to go through to make sure that those two devices are paired successfully. This is not only a process that ensures security, but it also makes sure that you're able to connect to that device automatically later on. This process commonly uses a personal identification number, or PIN, to verify the connectivity when you set it up initially. And fortunately, you only have to go through this pairing process one time for a piece of hardware. Once it's paired, you can connect and disconnect from that Bluetooth device, and you don't have to go through this pairing process every single time. Although the Bluetooth pairing process is very similar between devices, there may be nuances or differences depending on the device you're connecting to. So check your documentation to make sure you know the appropriate personal identification number or where you would find that information on your Bluetooth device. You would start the pairing process by enabling Bluetooth on both of the devices that will connect to each other. If you are an iOS or Android user, you'll find this Enable and Disable function under Settings and Bluetooth. You would then set both of those devices to be discoverable. This may require a specific key sequence or startup process, so make sure you check your Bluetooth device documentation to know how to put your device into a discoverable mode. Once you do this, you'll see devices start to appear on your mobile device, and then you can select that to begin the pairing process. Before the pairing process completes, it asks you to confirm a personal identification number. This might be one that is embedded into the Bluetooth device, or it may be dynamic so that it changes every time you try to pair with that device. Again, your documentation will tell you where to find that PIN, and you'll need to confirm that PIN or type it in on one of those Bluetooth devices. At that point, the Bluetooth pairing process is complete, and those two devices can communicate with each other. You can test this by powering down one of those devices, powering it back up, and making sure that it's able to automatically reconnect over the Bluetooth connection. If you've ever used the Maps functionality on your mobile phone, then you know that GPS capability can be very helpful. GPS is the Global Positioning System, and it's a technology that was created by the United States Department of Defense. This technology uses satellites that are circling the Earth, and if you can see 4 of those satellites with your phone, then you'll get accurate GPS readings. This GPS functionality uses differences in the signal that is received from these multiple satellites to determine your longitude, your latitude, and the altitude above sea level. So if you're using Maps or you're using an app that has location functionality, it may be using GPS to determine that. But GPS is not the only way to determine where you are. Some apps use the Wi-Fi networks that are around you to get a better idea of where you might be, even if GPS is not currently available. And some cellular networks are able to triangulate based on the different cellular towers to determine where you might be as well. So if you are having a problem communicating or receiving GPS signals, you may be able to use these other technologies to locate where you might be.